So once again, let's talk about Charles' law. Okay, so in our previous class we talked about Charles' law, and we talked about the fixed mass of gas. The definition, for fixed mass of gas, the volume is directly proportional to its absolute temperature. Okay, the thing that differentiates between Charles' law, the thing that makes Charles' law very different is the word absolute temperature. Okay, and we looked at the graph that involves absolute temperature. Okay, when we say that, when we talk about absolute temperature, okay, we need to talk about the unit of Kelvin. Okay, which means that when we answer any question, okay, that has to do with Charles' law, okay, you need to make sure that your temperature is always in Kelvin. And the first thing we did yesterday was to look at how to convert degrees Celsius to Kelvin. Sorry, on Monday. How to convert degrees Celsius to Kelvin is by adding 273, and then terbaliklah kalau kamu mau tukar daripada Kelvin balik kepada degrees Celsius. So this brings us to our question over here. Okay, so the actual answer is 202. Okay, and I purposely asked this because there are 5 people that voted for 222.22. Okay, and this is a very common thing that we see in the objective question. Objective question, this answer will come up and this answer also will come up. Because a very important thing about Charles' law that students always forget now is that when you use the Charles' law formula, the temperature must be in Kelvin. If you did 200 over 27 equals to V2 over 30, you will get V2 equals to 222.22. Okay, and then when you see this answer option, you won't even think twice, okay, the answer is A, macam tu. Padahal, right at the get-go, you have already done the wrong thing, which was not to convert which was that you didn't convert the degree Celsius to Kelvin. Okay, I'm going to stress this now, and I'm going to stress this again later because we're going to look at another law which involves the temperature in Kelvin. Because the definition for Charles' law is that volume is directly proportional to the absolute temperature. Okay, absolute temperature must be in Kelvin. So write down there next to your notes or whatever lah. Okay, put a reminder to yourself, highlight it, put a sticky note or whatever. Write down there, change the temperature to Kelvin. There are only 2 instances where you will have to do so. One is when you use Charles' law, and secondly is when you use the pressure law, okay, which we will come to in a little while. Okay, so for the 5 people that got 222.22, okay, we learn from this mistake. Okay, we learn from this. It's okay that you made this mistake now, but let's learn from this. Okay, the formula is easy, but make sure that you don't make the mistake. Okay, now in this case, it's also the same. We don't think about the pressure because remember when we were doing Boyles Law, right? We say that, oh, okay, we have to add the pressure from the atmospheric law and then plus this one. But because in Charles' law, pressure is constant. So we don't even think about the atmospheric pressure anymore. So it's just this 29 over 17 plus 273. Okay, and then divide by 57 plus 273. You will get 33 centimeter cube. This one is even more interesting. Out of the 17 people that voted, right, 7 people got 97.24. Okay, 97.24 because you forgot to convert the temperature into 273. Okay, so when people answer this, they're like, both also you plus 273 ma. Why is it a different thing? Of course it's different. Okay, mathematically, when you add this, it changes a lot of things. Okay, if you don't add this, it changes a lot of things. Okay, so I want to spend the first 10 minutes by discussing these two questions, just to drum in the fact okay, just to drum in the fact that when you calculate the temperature must be in Kelvin. Okay, yeah, so I guess this is where Chen-Hee realized that he did wrong because he forgot to, right, Chen-Hee, you forgot to change the temperature to Kelvin. Okay, so I'm going to end the poll. Thanks to the 17 people that did this. Okay, I don't know what happened to the other 3 people. There are other 3 people here but not here, or are you like Okay, but okay, fine, whatever lah, doesn't matter. Okay, so today we are going to look at the third and the final law, okay, in gas laws. Okay, now this is known as pressure law, okay, otherwise known as some other guy's name lah, okay, which I will come to in a while lah. Okay, so we have to know what is the law, we have to draw the graph, which we already did, okay, so I'm going to explore this, and then we have to explain the law by using kinetic theory, and we have to solve problems, and we have to talk about the meaning of absolute zero. Okay, let's talk about this in a little while. So, let's imagine a situation where you have gas molecules in a closed container, and sorry, instead of changing the volume, you change the temperature. Sorry, oh my goodness, what am I saying? Okay, instead of maintaining the pressure, you maintain the volume now. So the amount of space that the gas can move in is the same. But what you do is you increase the temperature. Okay, you find that the higher temperature, the molecules will move faster and there will be greater pressure. So explain what happens to the gas molecules when the gas is heated. Okay, the kinetic energy of the gas molecules increase. This has something to do with temperature. Why does the kinetic energy increase? Because we increase the temperature, we're giving it more heat. And because of that, they move faster and collide more frequently. Okay, compare it to when we were talking about Charles' law. Okay, when we're talking about Charles' law, what we are doing in Charles' law, hold on, let me see. Okay, when we were talking about Charles' law, in this case, okay, we are maintaining the pressure. So we increase the amount of space so that the pressure can be maintained. Okay, that's Charles' law because we want to maintain the pressure. But in the pressure law, nama pun pressure law lah. Okay, the thing that we don't want to maintain is pressure. We want to change the pressure. So we maintain the volume. Okay, we increase the temperature, we maintain the volume, and so because of that, the gas pressure will increase. Okay, so the rate of collision between gas molecules with the wall of the container increases. There is more, there is more collision, okay, with the gas molecules and the walls of the container. If you remember from our first class, I told you already the three things that explain pressure, volume, and temperature. Okay, temperature is explained by the kinetic energy of the molecules. Higher the temperature, the higher the kinetic energy. Volume is explained by the amount of space. The volume of the container equals to the volume of the gas. And the third one, which is the most difficult one, is pressure. Okay, pressure is explained by the rate of collision between gas molecules and the wall of the container. Okay, if let's say this is the container and this is let's say this is the container and this is the gas molecule okay, kalau dia berlanggar macam ini, less pressure. Tapi kalau dia berlanggar macam ni kan, okay, much higher pressure because there is more collision in a short amount of time. So that's why we call the rate of collision between the gas molecules and the walls of the container increases. When that happens, gas pressure will increase. But remember, the condition for this to happen, okay, the condition for this to happen is that the volume must be maintained. Okay, and we maintain it by having a closed container. So this doesn't work in a balloon, because balloon, the volume can change, and the balloon can expand, the balloon can, deflate. Okay, so we want to have a container which is closed and you can maintain the volume. The volume doesn't change, okay, even if the pressure changes, because that's what pressure law is all about now. So the relationship between gas pressure and temperature, if the volume of the gas is kept constant, is as the temperature increases, the gas pressure increases. Okay, when the temperature of a gas increases, the kinetic energy of the molecules increases. This is the explanation behind this. Okay, the molecules move faster and collide more frequently with the walls of the container. Therefore, the gas pressure increases. Basically, the same thing that you wrote over here lah. Okay, basically the same thing you wrote over here, they're just repeating it for you. Okay, kinetic energy increase means the molecules are going to move faster, and since the molecules move faster, they're going to bang or they're going to collide more frequently with the walls of the container. And when that happens, the gas pressure increases. Remember, the key to explaining gas laws is to understand how you explain volume, temperature, and pressure. Okay, volume is the volume of the container, temperature is the kinetic energy of the molecules, and pressure, okay, is the rate of collision. Okay, the higher the rate of collision, the bigger the pressure. Okay, makin banyak pelanggaran lah. Okay, makin banyak pelanggaran, makin cepat pelanggaran, okay, then your pressure will increase. Okay, pelanggaran antara molecule gas and the wall of the cell. So when you were drawing the Charles Law graph, this is what you got. Okay, and the same thing which I'm going to ask you to do today lah. Okay, I want you to extrapolate your graph. Okay, and theoretically, if you extrapolate, okay, you are going to get the value of negative 273 degrees Celsius, which is the exact same value as the one that we discovered in Charles' law. Okay, when there is no volume, the absolute zero temperature is negative 273 degrees Celsius. Even when we do Charles' law, at zero pressure, okay, at zero pressure, the temperature of the gas molecules is negative 273 degrees Celsius. That's why this temperature, negative 273, is called the absolute zero temperature. Okay, in Malay, it's called suhu sifar mutlak. Okay, absolute zero temperature. Why is it absolute zero? Okay, because this zero refers to zero volume, okay, and zero pressure. When there is no volume of gas, when there is no pressure of the gas at all, okay, it can only happen, okay, at negative 273 degrees Celsius or 0 Kelvin. Okay, that's why dia adalah absolute zero. Okay, P0, V0, T also zero, but at Kelvin. Okay, and this law, okay, pressure law, so when we were talking about the first law, which is Boyles Law, okay, so Boyles Law, the thing that is constant is temperature. Okay, temperature is constant. Sorry, I'm going to draw this one. Okay, so Boyles Law, temperature is constant. Pressure and volume are related. In Charles' law, okay, the pressure is constant. Okay, and it is the volume and the temperature that change. Now, the pressure law is also known as this guy's law. Okay, I have this. Okay, so this guy, Gay-Lussac, okay. Some people like to say Gay-Lussac, and some people like to say Gay-Lussac lah. So whatever way you like to pronounce it, whatever it is, so here's a little bit of a fun fact about Gay-Lussac lah. Okay, so Gay-Lussac is a French physicist and chemist. Okay, he's from France, and he is the guy that discovered that water is made up of 2 hydrogens and 1 oxygen. This is the guy that is responsible for our H2O. Okay, he's the guy that discovered that, oh, okay, there's 2 parts hydrogen in water and there's 1 part oxygen in water. Okay, and he also came up with this law, okay, which we call the Gay-Lussac law or pressure law lah. Okay, and the thing that is constant in the Gay-Lussac law is the volume. Okay, so BT, CP, and GV. In Boyle's law, temperature is constant. In Charles' law, pressure is constant. In Gay-Lussac's law, otherwise known as the pressure law, the volume is constant. Okay, so the law states this: pressure is directly proportional to the absolute temperature of a fixed mass of gas at constant volume. Okay, so we find that in all the 3 laws of gas, all 3 also the mass of gas is constant. Okay, so Boyle's law is temperature and mass of gas. Charles' law is pressure and mass of gas. Gay-Lussac's law is volume and mass of gas, all always constant. Okay, but the important thing is this: please remember that when we're talking about Charles' law and Gay-Lussac's law, we need to make sure that we're talking about absolute temperature. We're not just talking about normal temperature. Okay, we're talking about absolute temperature, because absolute temperature is directly proportional. If you're talking about just temperature, okay, like in this case, if it is just temperature, it is increasing linearly. Remember the third type of graph that I showed you, increasing linearly? Yeah. So we have to be very careful when we talk about the three laws. Okay, because Gay-Lussac's law and Charles' law both refer to absolute temperature. And absolute temperature, the unit is in Kelvin. Okay, so be aware of this. So we come back to this thing again. Okay, remember the triangle? Okay, the triangle where this is P, this is V, this is T. So if you have Boyles law, okay, remember I said just now, Boyles law, temperature is constant. So you close the temperature. Close the temperature and then this will be this one. But since they're on the same line, it is inversely proportional. Okay, so P and V is inversely proportional. Now, what if you have Charles' law? Okay, Charles' law, when we did that, okay, Charles' law was, sorry, okay, PVT. Okay, Charles' law is pressure is constant. So we close pressure. So V and T, this is directly proportional. Okay, V and T is directly proportional, and that's why we get V1 over T1 equals to V2 over T2. Now we do the same thing for Gay-Lussac's law. Gay-Lussac's law, volume is constant. So you close the volume and you get PT is directly proportional. Okay, so since PT is directly proportional, this will be the formula that we're talking about. Okay, P1 over T1 equals to P2 over T2. Again, make a note in your module that temperature must be in Kelvin. Okay, not degrees Celsius. I'm going to write this very big because time and again people will always forget this. Okay. All right, so please be aware of this. Temperature needs to be in Kelvin, not degrees Celsius. It's just an extra step lah. Okay, it's just an extra step. So it's not that difficult lah. Just have to remember. All right. So these are the two graphs. Okay, this is the graph in degrees Celsius, which I want you to submit to me today. Okay, please submit your graphs. Okay, make sure you extend, and then find out whatever the value here is lah. Okay, if you did a lazy scale, which is like 50, 100, then you will get something very, a little bit bigger than normal. If you did a more small scale, like 20, 40, 60, then you will be able to get a more accurate reading. Okay, so please submit your pressure law, your Gay-Lussac's law into the Telegram today. Okay, so we find that when it is degrees Celsius, the pressure will increase linearly. Okay, increases linearly with temperature. But when we're talking about absolute temperature, which is in Kelvin, okay, we make 273 negative become 0. We will get absolute temperature is directly proportional with gas pressure. Okay, so be aware of this. The unit of the temperature tells you which words to use. Kelvin, absolute temperature. Degrees Celsius, temperature. Okay, but Gay-Lussac's law and Charles' law, okay, if you want directly proportional, you have to use the words absolute temperature. Okay, don't get it mixed up. Okay, let's take a look at this again, and we're going to do the same thing that we did the other day. Okay, please write your inference, your hypothesis, and the variables. Okay, let's build a little bit of skill. I'm going to give you 2 minutes, okay, to look at the situation. This is to determine the relationship between temperature and pressure of a fixed mass of and volume of gas. Okay, state down the inference. Remember how to write the inference. State down the hypothesis and the 3 variables. Then I will call 3 people to answer this for us. Okay, 2 minutes. Pressure depends on temperature. Pressure depends on temperature. Okay, all right. Hypothesis, Chloe, Vivian, are you ready?
Hypothesis. The higher the temperature, the higher the pressure.
Okay, very good. The higher the temperature, the higher the pressure. Remember, the order of this is very important because this guy is saying after the journey, it is found that the air pressure had increased. That means the air pressure is dependent on something else. Okay, so the order in which you write the inference and the hypothesis is important. Okay, very nicely done. All right, Vivian, are you there with our variables? All right, good. Temperature. pressure and volume of gas. But besides the volume, we can also talk about the mass of gas. Okay, let's put this where it is lah. All right, very good. Although I didn't hear anybody, although I didn't hear Leong and Vivian's voice, I was so hoping to hear their voice. Okay, fine. All right, so this is how the experiment looks like. Okay, you put the so you put the ice into the water so that it goes to a very low temperature. Okay, and then you have this gas over here that is closed lah. Okay, it is closed and it is connected to this thing that is called a Bourdon gauge. Okay, so this is called a Bourdon gauge, and the Bourdon gauge is like this machine that you see in a petrol station, right, where they go tang 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 when you want to. It measures gas pressure. Okay, so whatever pressure that is here is going to be measured by this thing called the Bourdon gauge. So at first, when you put ice inside, it's going to be low temperature. So low temperature, you expect a low reading of the pressure lah. Then when you heat it up, bila kau kasih panaskan, it's going to increase in temperature. And according to your hypothesis, the bigger the temperature, this Bourdon gauge, the needle over here is going to move higher lah. You're going to get a bigger reading of the air pressure. Okay, so in your in your module, can you please put a star down here, okay, or at this word, the Bourdon gauge, and then say that the Bourdon gauge is used to measure gas pressure. Okay, gas or air pressure lah. Okay, so just so that you know, okay, that the Bourdon gauge is used to measure the gas pressure. Please pronounce it correctly. It's called a Bourdon gauge, not a Bourdon gauge. Okay, I've always, because people think it's tauge, people think that it's called Bourdon gauge, okay, or gauge, or gouge. It's not even gouge. Okay, it's gauge. Okay, gauge as in engage. Yeah, things like that. I know English is just so weird. There's a letter U over there, but it's not even heard. Can Gauge, gauge. It's like totally senseless. Anyway, yeah, that's English for you lah. Okay, so this is the reading that we got the other day. Okay, and the conclusion will be P is actually it's not directly proportional, kan? If you look at the graph that you drew, it's actually P increases linearly. Okay, so please correct this. This should not be. This is P increases linearly with temperature. If we want to use the word directly proportional, we have to use the words absolute temperature. Okay, so please be reminded of this. Okay, so since we are doing pressure law, hold on. Okay, since we are doing this pressure law, what I would like you to do is I would like you to answer the next 4 questions lah. Okay, the next 4 questions in page 115. Okay, yeah, the next 4 questions in page 115. Okay, so so after the experiment, this is the state Gay-Lussac law. Okay, this is the mathematical expression. Okay, and these are the 2 graphs. Okay, all this is before the solve problems involving pressure law. Okay, and so now what I want you to do, I don't want to show you the answers yet because the next slide is showing you the answer. Oh, can lah. Okay, so these 2 questions, right? And then after that, these 2 questions. Okay, so what I want you to do is I want you to give this a try. Yeah, you know what? I want you to give this a try. Okay, and answer this now. And yeah, sorry, just give this a try lah. Okay, give this a try. Let's answer this now. Let's, if you're still answering, okay, you can continue, but let's go ahead and do this. Okay, so in the first situation, you are given 60 kilopascals and 90 kilopascals. So this is pressure. Okay, so these 2 are pressure, and all you have to do is just make sure that they are the same unit. So since they're the same unit, no conversion is needed. You can just use the number 60 and the number 90. Okay, so you get P1 equals to 60, P2 equals to 90. Now at 60 kilopascals, the temperature is 20 degrees Celsius. So T1 is 20 degrees Celsius. But, okay, don't forget that we have to change degrees Celsius to Kelvin. And so when we change degrees Celsius to Kelvin, we will get 293 Kelvin. Remember, because we plus 273. So my question now is, how do I find T2? Okay, and so you will get this answer lah. T2 equals to 439.5 Kelvin, which I asked you to convert back to 166.5 degrees Celsius. How do you do this? You minus 273. Okay, so 439.5 minus 273, you will get 166.5. Now, the interesting thing about this is this. 7 people voted for 30 degrees Celsius, and only 6 people out of the 13 people that answered this, you got 166.5. So the people that got 30 degrees Celsius, it is because you didn't change this one into Kelvin. No matter what, now, even if I ask you what is the temperature in degrees Celsius, right, you still have to change it to Kelvin first. Calculate and then change back. Okay, is it very troublesome? Of course it's very troublesome. I'm not saying that it's not troublesome, but is this the only way to do it? Yes, it is the only way. There is no other way you can get this answer 166.5 if you don't convert it into Kelvin. Okay, I can go on and on about the mathematical laws behind this lah, but I'm not going to, I'm not going to bore you with the mathematical laws. Okay, you have to change it to Kelvin, even if I'm asking you what is it in degrees Celsius. So change and then change back. Okay, you cannot directly do it, cannot, because the absolute temperature doesn't work that way. So I suspect this is why a lot of people are stuck in number one, because I asked the question, what is it in degrees Celsius? And then you're like, oh, but I got 439.5K. So you're like, okay, don't know how to change back. Cannot. Okay, so let's learn from our mistakes. All right, number two, same thing. Our temperatures are both in degrees Celsius. Okay, so no problem. So our pressure, since it is kPa, we can maintain it as kPa. Okay, but again, we need to change the temperatures to 200, plus we have to change it to Kelvin. Okay, and that's why we will get 323 and 300. Okay, 323 is from this 50 degrees Celsius, 50 plus 273, and 27 is 27 plus 273, you get 300. Okay, you get 387.6 kilopascals. These are not so bad. Okay, only 2 people voted for the other one, 666.67, and you know how I got that? Because I did 50 over 27 times 360. Okay, which cannot, because the temperature must be changed to Kelvin. Okay, reminding you again, Charles' law and Gay-Lussac's law, temperature must be in Kelvin for the calculation. Okay, then you convert back and forth as you wish. Question number 3. Okay, so the pressure is at 4 atmospheres. Okay, and the temperatures are both at 27 and 102. It is exactly the same as the second question just now, except that the unit for pressure has changed. Instead of using kilopascal, I have changed the unit of pressure to 4 atmosphere. So your final answer will be 5 atmosphere lah. Okay, ATM is the short form for atmosphere. Atmosphere is a unit, okay, for atmospheric pressure. Okay, so again, the good thing is 2 people still answered 15.11, and I suspect it's because you forgot to change the temperature into degrees, into Kelvin. Okay, so we learn from this mistake. All right. Okay, last question of the day. So motorcycle tire, yada yada. We have the same unit here, 3.2 atmosphere and 2.8 atmosphere, but we have the temperature. Okay, but the temperature is in degrees Celsius. Once again we have to change it into Kelvin. And so I guess it is because of this question, when I asked what is T2 in Celsius, only 13 people answered. Most likely because you got the correct answer, but you forgot that you have to change it to Kelvin. So the answer is negative 10.5 degrees Celsius. Okay, because when your pressure is lower, okay, your temperature will be lower. You expect to see that. Again, okay, again, you need to make sure that you converted already. Okay, because you're going to get it in 262.5. Okay, so maybe a lot of you are like, how come I don't see 262.5? What must I do? Remember that the final answer you get, that Kelvin, that answer is still in Kelvin. and I ask you what is it in Celsius, you need to convert it back by minus 273. So in this question, 23.625 is the more popular answer compared to negative 10.5, which tells me a very important thing about the people that answered this lah. Okay, for those of you who didn't answer, I don't know lah. Okay, it's like why you. Okay, I really hope that you put in effort. But for those of you who did answer, okay, I would like to strongly caution you about this temperature thing. Okay, be aware of what units you're using, because physics it's not just about numbers, the units also is very important. Okay, if it's just all about numbers, then we're talking about mathematics. Okay, but even at higher level mathematics okay, the units are very important. Okay, so we train ourselves to be aware of the unit. Okay, lama kelamaan kan, you will hear the same words from me. If you give me the answer 262.5, then I will ask you 262.5 what? Ringgit? Maggie me? Okay, fruits? Give me the unit. Okay, because a number without a unit in physics is meaningless. Okay, if you just give me a number, you don't give me the unit, it is meaningless to me. Okay, totally no meaning. Okay, just like whenever we say totally no meaning, and then people say, oh, just like the existence of my life. No lah, come on. Okay, everybody's existence has a meaning. Okay, so I would so what I would like you to do today, okay, what I would like to do today, as we end the class for today, number one, your homework is to hand in the graph that you already should have drawn. Okay, just take a photo of the graph that you already drawn, okay, and then hand it in into a Telegram channel. And to prepare for Friday's class, can you please answer the tutorial questions? Okay, try as much as you can to answer the tutorial questions as far as you can lah. Okay, just to prepare, because this Friday we're going to have a tutorial session. I know there's a little bit more that I need to discuss, the applications of gas law. So we will discuss that, and then we will go straight on into the tutorials. So that you learn better during the tutorials, prepare for the tutorials first. Okay, so it's not homework, but at least when I ask you questions, like you have an idea of how to answer the questions. Okay.